and for a while, and then probably went for school board, and then worked my way up in the state. And then in like 50 years, like I guess secretary of education.
Okay. That's a good goal. That's a lofty goal. Anybody would be better, not saying that you're just anybody, but we had Betsy DeVos for a while. I was not a big fan of that lady. I don't know who our new Secretary of Education is.
She's still secretary of education.
But who's the nominee?
I don't know about the nominee.
Yeah. Some of you guys have less than 5 minutes remaining. Too bad. It showed your time clicking at the bottom of it. No, I mean, it showed the clock at the bottom. Are you still taking? Oh, no, wait, I tried that too. Oh, are you still taking? All right. I will start in 1 minute. Most of you guys have finished. In the meantime, since most of you guys have finished, I just want to remind you that we did miss 2 days last week. Because we missed 2 days, I did move the quarter project back 2 more class periods. So instead of it being due the March 1st, it's due March 5th. If you need like an example, I made an example for you, which I thought was good. It wasn't near as good as I bet many of you guys do. I did it in an hour, but it wasn't too bad. And I put it under the asynchronous lesson right here. In fact, I want to pull it up. See if I can do that while I'm waiting. What does my example look like? I listen to myself and I go, what the hell was I thinking? 5 and 3 and the opposite of it. Yeah. I think I did a pretty good job with that, considering I'm not a computer specialist. My virtual model made of batteries and buttons and gumdrops and rocks. And my justification for each one of those pieces I thought was pretty good too. You might want to go back and review that yourself. It's under asynchronous. I thought it was, and the buttons all represent, like everything is there on that's on the rubric. I've got it there. In the meantime, I do need to get started. Oh, got somebody in the chat that wants to say something. Participate in the project questions, like being under the seconds. Yeah, if you want to. Yeah, I actually have office hours. Today's the last day I'm going to be doing office hours on Thursdays and Fridays. I'm starting with freshmen on Thursdays and Fridays next week. So I do have office hours today. I have a meeting tomorrow and will not be able to have office hours. I have a meeting after school, and then I have an appointment with my surgeon. All right, I have to get back to today. So let's get to today's lesson. And we're going to learn about transcription and translation. This has the advantage of being one of the easiest things that you're going to have to learn in genetics. Honestly, this is probably one of the easiest things that I would expect probably a 25 to 30% increase on the next quiz. There will be a next quiz over what we're doing. Or will be an assessment over what we're doing today. So first step, what is dogma? What is dogma? What is dogma? And then, what is there a dogmatic principle you or your family hold? This is a SAT term. This is a SAT term. What is dogma? I'm giving myself 20 minutes. What is dogma? I'm sorry? Yeah, there might be a movie named after dogma, but there's a reason they named it. What is dogma? You don't look up images for it. Look up the definition for it. And is there a dogmatic principle you and your family follow? I never did see that movie. Well, you're welcome to come on here and say something, dude. There are some principles. It's a principle. It is a principle. So is there a principle that you and your family hold? Yes, and it's a principle that you and your family do not question. So is there a dogmatic principle that you and your family do not question? It's an unwavering principle. So if you're a dogmatic person, usually it means that you're unyielding or unbending and that you hold very true and solid to a concept or a principle that you do not violate. There you go. So thank you, Turner. Go to church every Sunday. That's a principle of my family. So if you're a Christian, that would be an example. All Christians universally agree upon that Jesus was the son of a God and then died and then rose from the dead. That would be a dogmatic principle of the Christian religion. If you are a Muslim, then you would say that that wasn't true and that there was only one God, not multiple gods or a trinity, and that Muhammad was the last and final prophet of that would be dogma. Those are examples of religious dogma. What we're going to do today is look at dogma of genetics. And this is the cool thing about this is there's only one violation to this. And I won't teach it to you until we get to viruses and diseases. And I am literally going to avoid that for the time being. So everything that you have to go through, and at least on the next quiz, if you follow dogma, you almost can't go wrong because it's unwavering, it's unyielding, it always is true, at least in the next assessment. So in this case, let's get to work. Well, transcription and translation, what that really means in these terms, I want you to think about transcription is taking words. And so think about it this way. Let's say this is going, I'm going to say ugly. I like that word, ugly. Ugly. How do I write that in Spanish? And spell it. F-A-O? F-A-O? F-E-O. All right, take your mic in just a second, okay? I want you to say something, but wait till then. So this is going to be English. This is going to be Spanish. And this is going to be out loud. So this is from here to here, this is transcription. Going from one language to another language is transcription. Going from language, from the written word to the spoken word is translation. So I've got my lovely assistant here, U-G-L-Y-F-E-O and
Fail.
fail. That is translation. This is the spoken word. This is his beautiful mouth. He's a vampire. He's a vampire. So when you think about transcription, we're going to be thinking about it in this way. This would be the protein here. And how do we get there? That's the question that we're going to be dealing with today. It's going to be pretty straightforward. You'll see it's not too bad. So first, we're going to have a little bit of review. Remember proteins. Proteins are made of amino acids. A fundamental protein, a protein that is in this primary state, in its fundamental state, we call a polypeptide. I will be referring to these interchangeably, polypeptide and proteins. I will say them to almost interchangeably. But also remember, there are 20 amino acids for every protein is going to be comprised of these 20 amino acids. They're pretty fundamental. They're like the alphabet. And they are assembled on a ribosome. Very basic information. We've already looked at this last fall and again in this semester. Just as a review, these are all of these different amino acids. You do not need to memorize necessarily these amino acids. Just know that there are a lot of them. Also, they do have some things you do need to remember, though, is that amino acids are going to be comprised of carbon, hydrogen, oxygen, and nitrogen. This is how I would know it was an amino acid. Amino acids are going to, again, give rise to polypeptides. And a polypeptide is essentially going to be an immature protein. These will give rise to eventually to a protein. But these are basically the alphabet for my proteins. These are all my amino acids. Pretty easy stuff. So the question we want to really get answered today is, how do we get the genetic information in DNA to amino acids? How do we get a bunch of amino acids into a protein? How do we do that? And it's not that complicated. It's pretty easy. You just follow dogma and you almost can't go wrong. Replication, again, as you guys just took a quiz about, you can come in here and say DNA, the double helix is going to be unwind. Those bonds are going to be broken. It's to a single strand. Helicase will do that. We're going to form new DNA with polypeptide or DNA polymerase 3. But it's pretty straightforward. We're going to get a whole genome copied and replicated. And you got these base pairing rules of adenine pairs with thymine and guanine pairs with cytosine. Pretty straightforward. It's not hard to remember that. But what we've got to get done is now think, how do I get from DNA to RNA and RNA to protein? Again, this is the translation part, and this is going to be the transcription part. Transcription is basically taking one language and going to another language. So if going back to Turner's example, in Christianity, what was the original language that the Bible was written in? I'm sorry? What again? Oh, no, it was Aramaic. It was Aramaic and then Greek and then Hebrew, I think. Or maybe it was Aramaic, Hebrew, then Greek, and then Latin. It goes on and on. But it was Aramaic, and now but when none of us read that, most of us are reading it in English and Spanish. This is transcription, but then we actually say it. In this case, UGLY, FEO, you hear, that's the same thing. To actually speak those things, oh, I'm sorry, I mean, I'm sorry, what am I? Some differences between RNA and DNA. What are some differences? Well, these are pretty straightforward. And you do need to know these. These are easy for multiple choice questions. RNA is single-stranded. And instead of saying deoxyribonucleic acid, here, deoxy, well, we say it's RNA. So it's ribonucleic acid. That's pretty easy. The bases are going to be different. So you'll see here that I've got these three are going to always be there. Cytosine, guanine, adenine. What's different is that there is no thymine in RNA and no uracil in DNA. Pretty easy. They're all going to have a sugar. In this case, the sugars are going to be the deoxyribose and the ribose. Phosphate groups are the same. The bases are they all have nitrogenous bases, but you do have a difference between thymine and uracil. There are some differences. Transcription, again, we're going from a double-stranded molecule. This is going to be here. This is my DNA. And then I'm making a single-stranded molecule of RNA. But how do we do that? And it's not too difficult. There is some new base pairing rules. So you do see cytosine still pairing with guanine. That's going to be the same. But in this case, when I'm going from DNA to RNA, when I'm going from DNA to RNA, since RNA doesn't have thymine, you'll pair adenine with uracil instead. And I'll give you some examples. We'll do plenty of examples before we move on. Let's try it now. So let's start with Caleb. Caleb, you're going to do the very first one. So one thing that you want to remember is when you do this, you want to do it in triplet. So I'm going to put it in triplet. So you give me the first three bases for TAC. I'm going from DNA to RNA. What would TAC go to? What would be my base pairs? I'm sorry? I just went through this. You can take a look. Look at this. Don't look at me. Look at this. Look at the screen. We ain't got time for this. Come on. The AUCG. Now here we go. What is that TAC going to give me? The question is, And don't worry, some of you guys are gonna get these others. You might want to be thinking about these others. I'll be calling on some other people in a second. Okay, thank you. Well, Manas, you just did it, but what I want you to do is you need to do it in triplet. You're putting a comma between each one of them. I appreciate it, but what is TAC gonna be? T goes to? Okay, so give me what you think. You got 3 of them. I'm gonna pause the clock. You want to talk to somebody in here? You got people to talk to, but everybody's waiting on you with bated breath. You can start talking to the kids in here. You don't have to do anything other than just talk to me. You can look at it and just say it. Okay, AUG. Let's see. Well, I say let me see. Shoot. Well, then plug it in. Okay, all right. So AUG, you're correct. Next person. Let's try this now. So Yahir. No, I have heard enough from Yahir. Abel. ATA. What is that going to be? AUC? I don't know. Adenine doesn't pair with adenine. It would be adenine. Remember, you drop the T and add the U. So it'd be UAU. Try again. GCC. Try again. One more time. CGG. Sounds good. Excellent. Now let's go to Randy. Randy? I'm sorry? ACU sounds delicious and nutritious. Going to go to Abilene Christian University. All right, Daniel Rosales. UCG. Okay, so the thing to remember is also it's a new term. These are what we always do this in triplets. Always do this in triplets. I color coded them for you. A trick to do this and to do this fast is to do it in triplet form. We're going from DNA triplet to RNA. These are called codons. Each one of these is called a codon. These are all going to be codons, and you're going to be using them very soon. These are all going to be codons. I got a question in the chat box. Let's see what we get. Thank you. Oh, thank you. Ice. You were paying attention. Okay, so major players. Who are my major players? And we're not talking about Monas on the baseball field. You're going to have mRNA, and mRNA is what we were making. This is what we call our primary, our very first transcript. It's our primary transcript. And I'll try to go back. Yeah, this is going to be the code that is copied from DNA. This is my mRNA. We call it mRNA for messenger. This is a messenger RNA. It is my messenger. And a messenger goes from one location to the next. In this case, this is all occurring in the nucleus. And it's going outside of the nucleus. It can move through the nucleus. Remember that the nucleus has pores in it. The nuclear membrane has holes. These are my pores. And these pores are openings, just like the openings on some of you guys' faces where you got pores and blackheads in them. This has pores where mRNA transcript can get through them. So this mRNA transcript can move through these pores to come outside of the nucleus. It is a messenger. It is going from the nucleus out into the cytoplasm where it can bind with a ribosome. Here again, Here you can see it. Don't worry about pre-RNA. This is something that we'll deal with the week before spring break. It does go from pre-mRNA to mRNA to mRNA, and it is going to be here. You can see we're going from this process is going to be transcription. This is transcription. We're going from one language to another. We're transcribing, and here we are translating. Now we're going from RNA to a protein, and this is, well, shoot, my polypeptide, and this is going to be my translation. This is actually saying it. We're going from transcription to translation. This is DNA to RNA, DNA to RNA, and this is going to be RNA to protein, trying to write sideways. These are my major players. My ribosome, you guys have probably remember this from 9th grade. This is ribosomes make protein. Well, let's not say make, let's say they synthesize protein. They use the code in mRNA to make this polypeptide. So transcription is done. Now what? What do we do with this, right? So, well, there's a lot of different things that can be done here. So remember, you're going to have to mature these proteins. They leave the pore, the mRNA leaves the pore, and then it goes to a ribosome, and then translation can begin. But how does that actually work? How do we read that? How do we read that code? Well, the ribosome is going to grab that RNA, and it uses another molecule. So again, this is my ribosome. This is my ribosome. This is my mRNA. And then we have something here called tRNA. Now, this was in the reading. Who can tell me what T stands for? I know M is messenger. What does T stand for? This was in the reading that I assigned. Excellent. We've got some answers here. Good. Nope, not quite. Do you want to look on with me? You can look on with me. Well, then you can go on your phone and you can look over my shoulder. There's a stool right there. Not quite. Not termination. There is a termination signal, but not quite. There's another term. It's in the reading. Let's see, I got a lot of guesses, but nobody's guessed correctly yet. Ah, you got it. Ooh, man, there's a bunch of you guys. Jesus. Yeah, okay. Yeah, there it is. Transfer. So this is transfer RNA. So I am transferring something. This is my amino acid, and this is the tRNA that transfers the amino acid to this. These are little rules to remember as well. So here's my tRNA again. This is my tRNA. It has a code. So we went from DNA to RNA to another type of RNA. And this is, so we had AUG, that gives me methionine. The thing that you have to remember is you always are going to be using this to code. The codon is important. This is called an anticodon. It is not going to be the code. It is not code. Anti means not. So we're going to be just moving along. So you can imagine this is a ribosome. It's going to keep moving down and adding these little amino acids as it goes. As it goes, it will just keep adding amino acids to it. This is what tRNA would look like. This could be any amino acid. It doesn't matter. This is called an anticodon right here. Anti means not. So this is code, not code. You are not going to be using this for the code. You're going to be using this in a moment to be, figuring out some code. And it's not hard, but do not use the anticodon. This is the #1 mistake I see students make. 5 to 10% of students will use this as the code, and it is not the way to do this. I'm not really going to go through this. This is easy. You can come back and look at that. That is the codon. What I do want to do is practice actually transcribing. So you do remember this. You do have to use 3 bases for 1 amino acid. So we're going to use 3 bases, just like we did before for 1 amino acid. And let's practice this. So here's my genetic code. Perfect timing. This is about where you guys are about to take off and start using this. Here's my genetic code. How do this is what we call a codon box. You could also have a codon wheel. We're going to use both of these today. And you're going to use this table to figure out what the code is. It's easy. So I'll do the very first one. So remember to always break these up into triplet. Always break these up into triplet as we do this. So I'll do the very first one. So the very first one is going to be ACG, easy. A pairs with adenine pairs with uracil, cytosine pairs with guanine, guanine pairs with cytosine. Then I'm going to go here and I'm going to look for UGC. So here's my first position, U. G is my second position, G, and then I'm looking for C, cytosine, UGC. That should be cytosine, and it is. So the next one, we'll go to Daniel Rosales. You've got ATA. First, give me the codon. What is the codon? What is the mRNA? UAU is correct. Now, what does UAU code for? What amino acid do I get for UAU? TYR, UAU is correct. TYR. It's not that difficult. We're cooking with Crisco. So let's try another person now. Let's go to Randy Rosenbaum. CCC, cytosine, cytosine, cytosine. Triple G. That's right, triple G. Now, what is my amino acid? I'm sorry? Glycine, GLY. You are correct, ma'am. You are correct, ma'am. This is lovely, lovely, lovely. Let's go to our next lovely consist. Let's go to WICE. WICE. TGA. Segal. ACU, she says. She is correct. Now, what amino acid do I get? That's why I love this class. This is my favorite class. I've got ice in here. What's my amino acid, sweetheart? You transcribed it. Now you've got to translate it.
Oh, I couldn't write it. It was THR.
THR? What? Look at you. Now, the last thing, I'm going to mess with y'all. ACT. Oh, shoot. And I did it for you. Dadgummit. What's wrong with me? You know, I'm surprised many more of you guys don't make fun of me and say, dadgummit, Mr. Pope. Y'all say all sorts of things. My kids last year would ride me if I ever said anything like that. They're like, dadgummit, redneck. What are you saying? So I go ACT, UGA. UGA does not code for anything. UGA codes, well, not an amino acid. It codes for stop. I want you to think of this like writing a sentence. Every one of these is a letter or a word. Eventually, all sentences have to have some sort of punctuation. In this case, stop is a period. How many times do you guys see stop? How many times do you guys see stop in this chart? You are correct, sir. There are 3 of these. There are 3 stops. Once you hit a stop codon, you are done. Now, these are some words to live by, but let's do some practice. Everybody should go to the review. Make sure you're on Schoology. We're about to get to work. Ain't got time for all that. Ain't got time for that. Ain't got time for that. And guys, this took me forever to put together, so dig in. This took me forever. All right, let me see. Genetics. Let's go to transcription and translation. And you're going to work in groups, but you're only going to work in groups for 10 minutes. Then I'm going to break you guys up. You're going to do this independently. You're going to have 10 minutes to work together, and then you're going to have 10 minutes to do work separately by yourselves. You kids in here, y'all are going to have to talk to each other. In this case, for sure, Caleb, you're going to have to be doing this since you don't have a charger. I'm going to see if I can find you a charger. In the meantime, you can be working with somebody else 6 feet behind them. All right, I'm going to open this document. I've got this document open. Now, you can see this. Can I see your computer? make that screen big because you need to see what I'm doing. All right, what I have done is I have broken this down into another way, and they use both of these on the IB exam. Sometimes they give you a codon chart, like that we were looking at before, first position, second position, third position. Sometimes they give you a wheel. I much prefer a wheel. You kids that are in here, you're gonna be doing this on paper, so you don't have to deal with this. So you can still be doing this on paper. Caleb, I just was realizing I made copies for you. I don't know why. So I'm going to do the first one. I'm going to make a copy of this, though. I think I already did. This is my copy. Okay, there we go. I'm going to open up a copy so I don't write on yours. Yeah, I know, but if I write on the original copy, it'll screw up your copy too. I've got to make a copy of the copy. Okay, so the first one, let's see. I got DNA triplet, right? So DNA triplet, I'm going to go for mRNA to go backwards. Adenine pairs with what in DNA? What would I pair with adenine? Well, that's thymine. So let me put that on thymine, and then guanine here is going to be paired with cytosine. Uh-oh, I got somebody texting me, or not texting me, but chatting with me. Excellent, you got it. You got it, George. You got it, George. And then we're going to go to tRNA. Now, remember, tRNA is not the code. Remember, not the code. You never code from here. But nevertheless, I need to know what that tRNA would look like. And of course, adenine, now we're in RNA, is going to be uracil, UUC. Always code from the code on. The code on holds the code. This is the thing. I keep saying this, but I see kids do this every year, and they just get nervous and they start looking at this because it's the last thing on the list. How you do this is AAG. So let me look. First position is in the first circle, inner circle. A. Second position, second circle. Third position, third circle. So A, G, lysine. So I'm going to put LYS. Done. And abbreviating it is fine. Don't worry about it. I'll do one more. GGC, CCG. Then I'm going to go back. It'll be the same. GGC, CCG, CCG, proline. Excellent. I love you. Your mama loves you. Everybody loves you. We're all cooking with Crisco now. Now, here are some questions and some things that you have to fill out. You're going to go through this like a knife through hot butter, but you want to share your screen because there's going to be a friend. You're going to get comfortable and you're going to start making mistakes. Work with each other and for 10 minutes, and then I'm going to break you up and you're going to work alone for 10 minutes. I want to be checking people in here especially. Sorry, you kids at home, I can't see what you're doing. Not in there during those 10 minutes. So I'm going to stop sharing my screen for a moment. I'm going to break you guys up into bands. 1, 2, 3, 1, 2, 3, 4, 5 is, yeah, let me do 6 groups. That's going to make it a little harder. Okay, you guys are in groups, open that up and start to work. I'm going to bring you guys your own copy. So you would much rather do this on much rather do this on. You don't have a pencil, is that correct? You do not have a pencil, is that what you were saying? Yes or no? No. Okay. Who does? Not just you? You too? Oh. You might want to check and see if that's oh, did I give you the same thing I had before? How did I give you the same thing I had before? What did I do? Sorry. What is it? I gave you a new one, right? Yeah. Yeah, here. I don't know why I did that. Yeah. You got a wheel right there. You can write on that one. You got one to write on.
Okay. Can y'all hear me?
Yeah, they can hear you.
Oh, okay. Good. So
What's up, baby? Oh, hold on a second.
should we fill in the chart? I don't know. I feel kind of awkward talking to myself.
What do you mean? Were you in the same record? Yeah. Yeah, let me shuffle the deck. I'll shuffle that deck. All right, I'm gonna shuffle the deck. How did that happen? What were the chances? What grade room are you in? I'm talking to somebody else in here, I'm sorry. Okay, let me see how this group's doing. So, okay, I'm back with you guys. You guys stuck?
Can you explain how to use the wheel again?
Yeah, so the wheel, so for this first one, AAG, remember you're coding from the codon, AAG, you go to the first position, A, so you're in this bottom left corner, A, and then G is lysine. You're working from your inside out. So first position, second position, last position, AAG is lysine. Do you see it, or can you point to it on the wheel? On the wheel itself. There you go. Now second A. Where's the second A? There it is. And then go to G. And then you can see lysine. So the amino acid is LYS, lysine. You got it. And then you got to keep doing that for all of them. Cool. Do the next one. All right.
Thank you for pointing that out.
Hello, beautiful people. Holy crap. So they got they were coding from the anti-codon.
Which you specifically said not to do, but yeah.
Everybody does it. I don't understand. I do understand. I think it's because it's the last thing you do, so you just instinctively do it. But
We're not supposed to do anti-code.
you don't code from it. You don't code from it.
So we don't have to do this part?
Yeah, you have to do that part. You just don't code from it. Yeah, do it. Just so because they may ask you to put that on there, but you just need to do it. So where are you coding from? Where do you code? Which do you code from, the DNA, the mRNA, or the tRNA?
The mRNA.
Okay, cool. So what's the amino acid for that one?
Lysine? Because I use this one.
Yeah, I know. So what's the next one? CCG. What is that?
GGC? I think you.
Yeah, but that's the tRNA. What is CCG for over here?
Oh. That's, protein.
All right, cool, protein. Well, breakdown. Hello, beautiful people. Oh my God. Are y'all going to share your screen? Somebody share your screen. How can I check your work if I can't see your screen? How can you have any pudding if you haven't had your meat? It's an old expression. There you go. You gotta let me see it. You gotta scroll down so I can see the central dogma. All right. Yep, so far so good. Oh, what is this? Why aren't you coding for your the third row? Whoa. Everybody stop. Hold on a second. You've got, look at your mRNA. You've got thymine in there. Thymine does not exist in RNA. You can't have ATT. That's probably why you're tripping. AAT. Okay, so how did you get lysine from TTT? How do you get that? From thymine? How do you get lysine? Oh, you. Okay, so you want to double check this. Hello?
Welcome to Spectrum.
There's no such thing as AAT, you just said that.
Yeah, there is no, you can't have a thymine. There's no thymine in RNA. Oh no, my battery's running low. How is this possible?
That doesn't make sense. Asparagus.
Okay, now, there you go. Now you're making some corrections. You guys talk to each other. Don't let each other make mistakes like that. You guys ask your groups if they want to still work together for 5 minutes, or if it's time to all go by themselves. Ask your groups. Hey, guys, ask your groups. You're gonna have to work individually at some point. So just want to know, what's the survey say? Ask your groups, yo. Do they want to stay together for 5 more minutes, or do they want to come out now? I don't know, just ask them, whoever you're in. Oh, you're not in there at all? Don't worry about it. All right, I'm gonna go 3. So are you telling him? Are you saying it to him, or are you typing it to him? Which group are you in again? Let me look, right here. All right. You gotta use your mic, yo. Oh, no one's sharing the screen. Hey, you gotta share your screen, Yost. But Jacob, share, if you've got it, just share your screen so I can see it. I know you're sharing your document with the group, but I'm getting word that there's a problem. We can't have any problems. What? It means stop. It means period. Like I was saying, you stop. You don't want to translate your whole chromosome, you hold all your DNA. Okay, so let's see. So this is an let me do CAG, I'm doing your third one. CAG is glutamine, you got that. AAU is aspirin, you got that. Where are you guys seeing that he's doing this? I thought you said he was translating from the tRNA. Oh, so he switched over at some point? Where did it start? Let's see. I'm gonna go to the 1, 2, 3, 4, 5, 6, 7th one. I'll start where you got GAG, GAG. GAG. You gotta scroll up a little bit so I can see the codon wheel. GAG is glutamine. So that's okay. So where are you seeing that he made a mistake? Tell him what row. Tell him what row. The 6th row, 1, 2, 3, 4, 5, 6. CAU. CAU is histidine. Yeah, that valine. You put it valine, and I think you went GUA instead of GAG on that 6th one. There you go. Kayla's got it. And the 8th one. You got to double check when you're doing this. It takes practice. That's why I did so many of these. It takes practice. So you guys are highlighting them for him? All right, I'm gonna let you guys work. I'm gonna go check over here.
Oh, you got that part?
Dude, what?
I thought we were just doing the front.
What are you talking about, dude? Caleb, there's other people that are trying to do work. Leave him be. All right, everybody will be in here in 1 minute. Yay. Okay, so we're all together again. All right. So looks like this group, I don't know how you got it aligned at left, was making some good progress. Which one of these do you think is the start codon? There's one codon that is code for start, and I don't know if anybody found that yet. Did anybody find that? It is AUG. It's not ATG. There's no, so I'm looking at yours, Carlos. It's AUG. Yeah, AUG. This is something you have to know. I'll give you some hints here, some things that will make your life easier, are to know 4 codons. You need to know your start codons, which is always going to be AUG, and you need to know your stop codons, UAA, UAG, and then UGA. You know those 4 codons, it's going to save you time. There's going to be times that you're going to have to translate, that it's going to be hard, and you need to be able to just know a few things. Now, when I made this for you, and you need to finish this, this is good practice for what we're going to do next. This, when you do this, make sure you leave gaps. Know that you're doing it in triplet. It's going to make a difference. This drawing, just like if you did the notes from last class, that drawing is going to help. I will see you guys Monday. There will be a quiz over transcription and translation. You guys be good. And I will have office hours today. Yes, I will have office hours.